All right, Algebra 1. It is the day you have been looking forward to ever since we started this chapter. It is the last thing in the chapter. And it kind of starts off exactly where it ends up where we started. Right? We were graphing systems, except for now instead of equations, they're inequalities. All right, so if you have the hang of graphing one of these, all right, we are at -1. That is the y-intercept. We're going to go up 3. 1, 2, 3, and over to the right one. We double check right here. It says greater than or equal to. Since it's equal to, we will connect them with a solid line. There we go. We're going to test. Where do we always test? 0, 0 if we can, because that means 0 is compared to being greater than or equal to -1. Is 0 greater than -1? That's true. And if that's true, that means I'm going to shade on the true side, which happens to be the left or the top, depending on which way your brain works. All right, then we're going to go to the bottom equation. It starts at +3. It goes down 2 and over 1. And you're saying, oh my goodness, they're not going to cross at a pretty little point, but that's fine because we don't care about a single point right now. All right, solid or dashed? Dashed. All right, I don't know who said that, but good job. I'm glad you knew it. All right, here's our dash line. We're going to test. Where are we going to test? 0, 0. There it is. And as we test, we say, is 0 less than 3? Is 0 less than 3? That's true as well. So that means on the bottom or the left of this line. And what we're looking for now, my dear friends, is the area shaded twice. Here it is. That is your solution. I don't need a single ordered pair. I need you to highlight all of the area in which it would be true. Okay, so that's everything to the left or the top of my maroon line and everything to the left or the bottom of my orange dashed line. Okay, that means any ordered pair I put in here will make both of these true. That's the whole thing. Okay, so you can practice along with me or you can just fill out your notes, but we're going to continue on here until we get them all done. All right, 5x equals 6. This one's in standard form, so you know what I'm doing. I'm finding x and y intercepts. So that's 1 and 1/5. 1 and 1/5 on the x-axis. That's about right there. And then I'm going to take this, -2y equals 6. So y equals -3. That's right there. I'm going to check it out. It says a dashed line. It doesn't say it. I just know it. And then we're going to test 0, 0. Is 0 less than 6? That's a true story. So we're going to shade to the true side. Everything's been true so far today. I'm getting a little nervous. All right, +1, -1, another dashed line. I'm going to test 0, 0. Is 0 greater than, right? -1 times 0 is gone. 1. Is 0 greater than 1? That's false. I knew I jinxed it. Okay, so no good here. We're going to the top. And we're looking for an area that is double shaded, and that is the top. Okay, so normally we're going to come up with some sort of like X or some weird shape. It might be squished a little bit, but hopefully they cross over somewhat like this. Happens almost all the time, unless we end up with parallel or perpendicular lines. Well, parallel. Perpendicular lines would look like this. Parallel lines. Okay, so again, we're going to continue with some of these. And now what I'm going to do here is I'm going to drop some of the information off of it. So y is greater than or equal to 2x. Where does it start? I don't know. Put a 0 on it, +0. That tells me where to start. Oh no, I can't use 0, 0. That's all right. I have a trick for that. 1, 2, 1. All right, my slope is 2. That's going to be a solid line. No, 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 no. There we go. I can't test 0, 0. So where's the next thing I should do? My recommendation is find something that's a double. That way, if I mess it up, I don't get the wrong answer. A double is right here, 1, 1. So I'm going to test right here, 1, 1. 1 is greater than or equal to 2 times 1. So is 1 greater than 2? I don't think so. I'm pretty sure that's false. So I'm going to go to the opposite side, the top or the left, depending on which way your brain's working on that one. All right, let's find orange for this one. Hoy, hoy. That's your hoy alert. It's a horizontal line at -1. So here's my -1. I'm going to make sure, yep, it's a solid one. Here we go, solid line. That's the best I can do right now. And here we want it to be greater than. Okay, so we should use some common sense here. Greater than should be above there. Okay, if you really, really, really are not sure what I just did there, test 0. Is 0 greater than -1? Yes, it is. So I'm going to shade towards the 0. Where is it double shaded? That's all I really, 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 really want to know. And that's everything up here. Right, double shaded. Okay, do you have to go crazy with the highlighter? No, I prefer maybe just like a circle, like draw a snail in there, something like that. That'd be good enough. All right, standard form. All right, let's get through these. X is -6. X is -6. Y is +6. It is a solid line. I'm going to test where it's 0, 0. So is 0 less than 6? Right, because 0 plus 0 is 0, less than 6. That's true. Shading. Again, don't go super crazy because we have a whole nother line to put on here. X is 2. Y is also 2. It is also a solid line. Testing out 0, 0. Is 0 less than or equal to 2? That's true. So I'm going to shade towards 0, 0. And I'm looking for the area shaded twice. Let's pick a different color here. Okay, so that's what I mean. So the bottom of that X is exactly what we're looking for. Looking for all those. All right, now a little bit of each here. All right, we are in slope-intercept form, so -4, and then a slope of 1, up 1, over 1. That line is going to be dashed. Is 0, I'm going to circle where it is 0 greater than -4? True. So we're going to shade towards that 0, 0. And here I got X, right? 2x equals 2, so X equals 1. And Y equals 2. That's going to be a solid line. That's a tall one. There we go. And testing 0, 0. Is 0 less than 2? That's true as well. So where is it shaded twice? Booyah, right here. So I want to make sure that you guys are good and comfortable with these. X, right? 2x equals 2, so X is 1. Negative Y equals 2, so Y is -2. I see a solid line in its future. Testing is out. 0, 0. Is 0 greater than 2? That's false. So that means where I just circled is false. So we're going to go to the other side. All right. X is 2. -2y equals 2. So y is -1. And that one's going to be dashed. And we'll test it out. Is 0 greater than 2? Right. So that's on the top of the line. No, thank you. Okay. So area shaded twice. Okay. We got this right-hand side of the graph. All right, now just like we had before, what we can do is ask you to write these inequalities. That went pretty well in class the other day, so let's see if we can continue on a roll here. So I know that this line right here is definitely a positive slope, so keep that in mind. And it starts with a y-intercept of 6. From here, it looks like I'm going to go up 1 and over 1, so I got 1x, or just x. And I'm trying to figure out the fact that this thing here is shaded this way. So when I test 0, 0 for this one, I want a false statement about 0 and 6. Well, I know 0 is less than, so I'm going to say that 0 is greater than, and it has a nice solid line, so I'll make it solid here as well. Then let's test the other line. It starts off at -2. In front of that, we're trying to find a slope. Okay, so from here, it looks like I'm going to go down 1, 2, right? My y values go down 2, and it goes from 0 to 11, so -2 over 11. And this one, when I test it out, look at this, it is shaded this way to get this taken care of. So I want a true statement about 0 and -2. Well, 0 is greater than -2, and again, it's a solid line, so I'll make it equal to. All right, look, some dashed lines this time. Ooh, isn't that pretty? All right, here's what we got. We got +2. Let's find a slope on this guy. I'm going to go down 1 and over 2. Down 1 and over 2. I got a slope. The next thing we're going to find is that it is shaded towards the origin right here. Right, I can see that. And that means I want a true statement about 0 and 2. Well, 0 is less than 2. I will not put an equals to on it because that would make it dun 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 wrong, and I don't like to be wrong. Nobody likes to be wrong. Look, it happens. Okay, but we're trying to avoid it here. -5x. All right, so that means I'm going to go up 5 and over 6. You don't believe me? Count it. All right, this time, notice this point right here, right? That means it's shaded over here, which means I'm trying to make a false statement about 0 and -5. Now, I know 0 is actually greater than -5, but I need to make it false. So I'm going to say less than, and I will not put an equals to on it because it's a dashed line. All right, let's take care of one more here. I think you got the point, but I wanted to make sure that we had a nice point here. I +2. All right, I'm going to go down 1 and over 1, so it's -1 for the slope. And it looks like it's shaded this way, right? So I want this to be true as I test out 0 and 2. 0 is less than 2, and that thing is solid, man. That's an awesome line. You can tell I didn't draw that one. If I drew it, it would be all wiggly and stuff. So here we go. Let's get the other one. Oh boy. Look, it's a vertical line. Man, what's it go through? It goes through X, so it must be X. And it goes through 1, right? Because vertical line, Vux, right? Vertical line, undefined slope, X equals. And it's just like the number line. It's shaded to the right, so that would be greater than, and it's dashed, so we're going to leave it just like that. Okay, so don't forget, we can have those vertical and horizontal lines. We're able to cover all those while we were at it today. All right, I think there's one or two more on here. Okay, by all means, you're going to give those a try, and we can check those out.